right. So I get the honor of going first, and I get the honor of talking about maybe the most exciting topic in big data today, data governance. Right? I knew you guys were going to finish exactly what I was going to say. So, as Max already said, so my name is Russ Savage. I work as an application engineer here at Cask, and we work with customers to solve their problems using Cask and its tools. And today we're going to talk about data governance. So just to show you, so who is currently running an active Hadoop cluster in here? Who is thinking about running an active Hadoop cluster? Who has run an active Hadoop cluster and is fed up with it? Nice. Well, we're gonna talk about a couple different things here. So we're gonna talk about the big problem that we see all the time when we work with customers. Talk about the wonderful facets of data governance, and I don't think that's going to be news to people, but a little bit how they apply to the Hadoop space. And then we're going to talk a little bit about how Cask is trying to tackle some of these problems and where we're going to go from here. All right. So anybody who's worked in databases or data sets or Hadoop, thinking about that elusive golden data set, right? You go around to different team members of your company, you gather requirements, you gather different sources of data, different teams, everything, right? You connect all the pieces together. It takes months, but finally, you've gathered everything together into this perfect, wonderful, golden data set, right? And it's perfect, and it solves all your company's problems, and you guys make $1 million, and it's fantastic. But as soon as you publish that golden data set, your data science team comes along. Oh, this is a great golden data set if it only had this extra column. Okay, I'll just make a copy of it. Oh no, this data set has too many columns. I just need 3 out of the 35. I'm just gonna, this is Steve's data set, this is Chris's data set. So you end up getting the same golden data set, start getting a couple more copies of it, right? And it's Hadoop, no one cares. There's copies of data everywhere, it's fine. But then you get more data scientists. And they start making more data sets, right? And pretty soon you get into a scenario where no one even knows where your golden data set is, right? So you spent all that time and energy building this amazing thing that you want people to use, and no one even found it, right? On top of that, you've got everyone who's using your cluster is using a different tool, right? This guy is using Excel, we just ignore him, he's not really. But the Python guy, the Java guy, the R guy, right? Everyone's pulling data out of your data set, everybody's accessing it using different tools, right? And everybody has their favorite tool, right? It's kind of like, everyone's got their favorite Android versus iPhone, that kind of stuff, right? You're not going to change them, so you just got to adapt to what they're doing, right? And as we said before, right, nobody cares how much data it is. Just throw it all in there, right? You guys say, we don't have time to deal with it now. Just throw it in there so I can talk to my golf buddies about how much data we have, and we'll figure it out later, right? So pretty soon, your data lake is turning into data swamp, right? Oh, someone else read this, right? So again, it shouldn't be news to anybody, but yeah, eventually, after you're running your cluster for a little bit of time, you start getting all these data sets, right? And it starts getting a little murky, right? Starts getting things that are growing in there that you're not really excited about. Apparently, is that kind of a flower? I'm not sure. But yeah, that's where data governance comes in, right? So this is the exact use case that people have been kind of developing data governance for, right? And data governance isn't a new topic. It's been around ever since there's been data. But people trying to take their golden data sets, their big databases, and make sure it doesn't turn into a swamp, right? And I don't think it's going to be news to anybody what the facets are. We'll just go over them just to make sure that we're all on the same page. But auditing, right? Who's got auditing in their cluster, right? Who's accessing data sets? Who's reading? Who's writing? Who's importantly who's truncating? Who's deleting? Who's deleting that shouldn't be deleting? Right? Collecting all that information and understanding what's going on there. Lineage is important. So you talk about where your data set's coming from. Right? Everything starts from this golden data set, and then it gets connected to other pieces and creates children. It creates children of children and grandchildren and stepchildren and all sorts of things, right? So being able to track that up the chain and making sure you can see where your data has actually come from is really helpful. Data lifecycle, policy enforcement, so you get into a scenario where you want to make sure that data is active for a certain amount of time, and then maybe it goes into an archive state, and maybe it disappears from normal people, from standard views, right? You want to make sure that you're keeping track of that, and the data that's relevant to at this particular time stays relevant. So keeping that life cycle going. Time to lives and all that auto expiration stuff. Data stewardship, curation, right? All the different ways that you can add additional information, along with metadata management, all the different information that you can add to data sets to make sure that when someone is searching for all your production data sets, they find all your production data sets. When someone's searching for particular data sets for a project, they can easily find it. Right? And normally, if you're thinking about how things used to be in big monolithic databases, a lot of the data governance pieces were kind of baked in. They had very, there was one layer on top of your database that was managing a lot of this stuff. But in the Hadoop space, it's not so easy, right? So Hadoop, you're storing all types of different data, right? You've got text files, you've got database dumps, you've got call logs, you've got images, you've got all sorts of stuff. And you've got, Internet of Things is coming in and bringing in all sorts of extra data. And so you've got a huge diversity of data in your Hadoop cluster. So managing this data governance across all those different types of data can be a challenge. And then, as we mentioned earlier, right? Remember this slide, right? Everybody accessing the tool from different, or accessing your data using different tools. Keeping the data, keeping the metadata, and keeping the information and data governance across all those tools can really be a challenge. Right. So how do you solve some of these? I don't think it's going to be anybody want to raise their hand and take a guess. I can see it because it's on the next slide. we already said it a few times, but we need more data about our data. Right. We need metadata. Right. So systems today, and many systems out there that do this, but the more metadata they track about the different data sets and programs and anything running in the cluster, the easier data governance becomes, right? So by tracking, tracking audit logs, right? Tracking audit information about people accessing your cluster, right? Lineage data, where the data comes from, right? All that is extra data that is about the data that's in your cluster. Lifecycle data tells you if it's on its way in or on its way out. We already talked about time to live and that sort of stuff, right? And the catalog, right? Making sure people can find your information, adding tags, adding properties, adding all this additional stuff, right? Metadata. It's exciting. It's important. It's in your cluster. If you don't see it, it's there anyway. Right, so I'm going to go ahead and say the richer your metadata collection is, the easier your data governance becomes. Right, that's kind of the whole point of giving this whole talk here. But I'm also going to take a little step further and say the more automated your metadata collection is, the easier your data governance becomes. And actually, one more, the fewer humans that are actually involved in your metadata collection, the easier it becomes. Right? Everybody makes mistakes. Everybody forgets to tag data sets. Everyone forgets to delete data sets after they're gone. If you could just have your cluster and your data and nobody else have access to it, it would be perfect, right? But you've got humans involved, so it becomes a little tricky, right? So the way you kind of solve this is thinking about the way we thought about this problem at Cask. Right, is to basically create a single layer that collects as much metadata as it can across all the different tools in your data set or in your cluster, right? And not a perfect diagram, but the whole idea is to keep a layer in between where your data is and all the different various pieces that are accessing it, and that layer is responsible for maintaining this governance, keeping track of metadata, actively pulling that information out of your system, right? And in the Hadoop space, you see a lot of diagrams. You see a lot of component diagrams with all different pieces. But the next one you see, ask if they have a governance layer in there because it's really important. Now at Cask, I'm not going to hide the fact that I'm from Cask, and this is Cask, and I'm wearing a Cask shirt. So we do have this Cask data platform, and that's what we work on, and that's what my team works on a lot. And the data platform is really basically our unifying layer. The layer in between, right? It's that wall that lets us track metadata across all the different products and all the different people that are accessing data in our cluster. I'm not going to spend too much time. This is like straight from our website, but this whole idea of having a unified layer lets us then build cool tools to manage metadata and data governance on top of it. And Tracker was the first tool I worked on when I got here in February. Right, so it's an application that runs on top of our platform. Right, it has a bunch of services and endpoints and reads a bunch of information that CDAP itself gathers about all the different components of Hadoop that it's interacting with, and then lets users discover information, track metadata, edit metadata, and it tries to make that as easy as possible. We're only in our second iteration, so we're still making changes, and I'll talk about a little bit of the changes that we're making in the future. We're really, right now, a metadata and lineage tool. I wouldn't go so far as to say we've got the whole data governance thing kind of figured out. We're still iterating, but we're working our way towards it, right? Every time we chip off a piece of the iceberg, it gets a little easier. And now I'm going to actually break and go into a live demo, which is going to be even more fun. Just to show you kind of what I'm talking about. I've got some slides, but those are some backup slides, but those are no fun. You guys can see all of this, right? That's great. Let's make this a little bigger. How's that?
Great.
Cool. So Cask Tracker, right? It's a product that we built to manage all the different metadata in the system. So here there's a search bar. You can search for anything. It searches over dataset names, column names, metadata, tags, anything like that. I've typed this in so I don't type it wrong. But clicking, I've tagged all these datasets with the word production. Obviously, some pretty exciting datasets. But just to use an example. So the whole point of this is to make sure that that people can find the information that they want to, right? Since this is, I'm going to click on this, which doesn't have a great information here, but I'm going to talk a little bit about audit logs first. Right, so we talked about the facets of data governance, audit log capability, tracking who's accessing, who's reading, who's writing, and from your data sets. Right, so this is anytime anything happens to this particular data set, we're keeping track of it, and we can then go back and audit it. So again, without having to go to the command line and do all that stuff, so it's easier for people to work with.
How do you generate an output log? Are there any agents that are tracking this?
Yeah, so
components, do you have to go to your Cask layer to gather the data, or it can work independently?
So anything that's going through the Cask layer, this data is getting collected automatically. If you circumvent it with your own stuff, we're trying to get better at collecting that, but it's like a moving target. Yeah, exactly. So we keep collecting it, keep getting better. But yeah, and that's what a lot of this stuff is. It's just making sure that you can capture that information at the right point. And Cask is flexible. The platform itself is flexible enough that we can keep adding that stuff in. Someday we'll have most of it, and then you'll invent something new, and then we'll have to add something else. So this data is collected from the CDAP platform itself. It's exposed RESTful services, so if you want to pull this into your own application or export it into somewhere else, get a different view of it, more than welcome to. But yeah, just making sure you keep track of who's collecting that information. And then go back and, all of this is time bound, right? So you can go back and figure out, this is really important for customers who work with in finance and healthcare, right? They look over a year, they see who's actually reading and writing from their data sets. This cluster that I have here doesn't have security enabled, but in actual production environments, you would have security enabled. You'd be able to see the user that's actually reading and writing from your data set. So critical for those applications. On top of that, we've got lineage. Oh, it changed since the last time I played it. But this is giving you a really funky visual representation of where your data is actually generated from. And what's interesting here is we can obviously track the information that's in your cluster, which is great. But even if you're loading stuff from, say, an external database or an external CSV file on some random server, we can at least keep track of the fact that it exists, and it exists somewhere, even if it's not in your cluster. So you can see where the data actually came from. Each of these are different tables that came through. You can see my data set is right in the middle, and then I can click on any of these arrows and try to find, go up and down the chain as I want. I don't know where the arrows are. They're going up. But yeah, so just a visual way to see lineage. Again, it's all time bound. So the whole idea is to make sure that you can track and see who is building data sets from your initial data set, right? If I'm going to make a change to my golden data set, I can now go in and I can see all the different people down the stream that I need to talk to in order to make that change. So it's helpful in managing that.
What's the real-timeness of your tracking?
What's the real-timeness? So all of the tracking is pushed through Kafka message bus. So as soon as the event happens, it gets pushed through. So it's a matter of seconds before it shows
So
up
I'm
here.
thinking if I'm a Chinese hacker or a Russian hacker and I've decided I want to get into the system, would you be able to pick that up?
I would say a tracker in its current form probably won't pick that up because if you're a Chinese hacker, you're probably not going through normal means to get at the data. But as I said before, we're trying to make sure that.
But if a user's identity has been subsumed by a hacker, and then all of a sudden he starts doing anomalous data queries, and he's got 8 months to do that because that's generally how long it is before he gets found. Would you be able to pick that up? And have
So I'll show you in a second. We have usage analytics, so you can see if users start accessing data sets that aren't being used. That's a good segue, actually. I didn't plan that, but usage analytics helps us figure out this is how many different applications are accessing this data set and how frequently. Now this is a test cluster, so I put some data in there today. Let's see if I can go back to 14. Yeah, so basically to answer your question, right? If you start seeing a bunch of audit logs coming through, but this data set is now being read by a lot more applications. And maybe as an admin, you thought that data set was actually on its way out, not on its way in. You can reach out and start asking some questions. Right? A lot of stuff is mostly so you can discover problems. The actual automated discovery of those, that's one of those things that we will build into the product as soon as we get the basics.
a little bit of AI.
Right, exactly. That's the magic. That's the magic. So again, this gives you an idea of how active your data set is. And if you think down here is this recent activity, I can see exactly when the last time my data set was read from, right, or written to. So if I'm a data scientist coming in and I'm looking at this data set and if it hasn't been written to in three months, yeah, I'm probably going to look elsewhere to do my analysis, right? Or if no active applications are actually reading or writing from it, it's probably not a really good data set. So just ways to tell if your data set is on its way up or on its way out. All those things. And then we talk about, let's see here, we're talking about metadata management. So clicking here, we can see a little more information about data set with additional metadata. A few screens a little cut off, which someone warned me about, I didn't listen. But on the left here, so in CDAP we have two main types of metadata. So we have system metadata in the form of tags or properties, and we have user metadata, same form of tags or properties. So system tags and system information is stuff that we obviously add ourselves. So not too exciting for this particular data set, but things that are added automatically by the system that can't be changed. And then you've got user tags, which actually let you edit and add new tags here, right? So I can add Meetup to here and And now if I search for things that go in Meetup, I get my data set back, right? So, so different ways to find information that you need. On this side, I've got, I can add a little more detail than just tags, right? I can add, you know, I don't know, it's some sample thing. That's why I typed everything in before, so you don't have to watch me do this. So you can put in whatever you want here and add it as a tag, and then you can search through that as well, right? So just users being able to curate their own data sets, and we'll talk a little bit about how we're trying to improve that going forward in what we're doing. Let's see here. I think those were the main pieces, and we've got a lot of other stuff. But again, this isn't a product demo. It could have fooled some people, right? So jump back to our presentation. See if I covered everything. Yeah. Okay. So like I said before, this is only our second iteration. We keep, we're agile, right? So we keep bringing this stuff, keep iterating on this. So we really want to start adding some more security around tags, right? So let's say you're a healthcare company and you tag your data as PII. That instantly flips so that only a certain group of people have access to that data. So security based on metadata tags is something that we're thinking about adding. I already talked about enhanced audit logs, so just getting a little more detail about what is actually happening to your data behind the scenes. Auto tagging data sets, that goes to the fact that you don't want people manually adding tags to all your stuff. So if you've got two parents that are both PII, or one parent that's PII, most likely your child is going to be PII. So propagating those tags down if needed. And trying to auto-tag those as much as possible. And then adding more metadata. So we're talking about data dictionary support. We're talking about more information that people can add so that they can discover the information in the cluster and keep track of it, right? You find a data set that has an entire dictionary applied to it, and it's actively being read, then that's a sign of a healthy data set, healthy ecosystem. Yep?
May I ask what's the underlying storage format for keeping track of this? I know some people are using graph databases for doing their MDM. Are you using a graph database?
Yeah, we have a couple different things behind the scenes, right? Cask is using we've got Hive Metastore, we've got HBase, we've got HDFS, all different Hadoop components that this data is being stored on. So different places depending on the different types of metadata that we're looking at.
So you haven't gone with an alternative representation?
No alternative representation. We're open source, we want to play well with everybody else in the space, so we try to store data in places that other people can access it to. Right, and Hive Metastore is what everybody puts a lot of metadata in, so we play nice with that as well. Right. So in closing, data governance, critical to success of your cluster. Right, long-term success of your cluster, keep your data from turning into a swamp. Right, multiple systems and tools, they complicate things. Everybody wants to use their own tool. Everyone wants to access, make a copy of the data for their own personal gain. But metadata is kind of the key to resolving a lot of data governance issues in your cluster. And I'm working on Tracker, our team's working on Tracker to help solve that stuff. And that's all I've got. So thanks so much. Any questions?
Yeah, question. So there are other projects that are trying to do that, other than obviously your bounded specifically to Meetup here. So you have the Palo Alto.
Right, Atlas.
We're a navigator, but that's also only commercial, so, and I think closed source as well. So, but Atlas is open source. So they're trying to kind of also support that space.
Yeah, so Atlas is a very, so he's just talking about other tools to collect all that information. So Atlas is an Apache incubator project that aims to do a very similar task for a lot of different projects in Hadoop. So we watch them very closely to see how they're evolving and how we can incorporate that. For the most part,
Portland works has it already.
Right.
It has support too.
So what we do is in the case of like Flutter Navigator or any of those things, right? We build connections so that any metadata that we collect, we can pump into those systems, right? So we try to play nice with any of the systems that are coming up. And there's, when you're building applications and running, there's just information that we can collect that sometimes they can't if they're looking at just logs and things like that. So we already have a connection to Cloud Area Navigator. The Atlas one, I don't know where that is on the roadmap. But we have an integrations tab that we push data in. And hopefully pull data out if they let us. So, cool. Yeah.
Thank you.
Next.
What are the slides are application and program? What's the difference?
Oh, application and program. So in CDAP, right, an application is basically a container around a series of programs, right? So if you've got 4 or 5 different MapReduce jobs that are running, those would be individual programs, and they're connected together with an application. I'm probably explaining that wrong, but that's how we think about it.
And these have to be written using something that here, or these will be able to.
So you can take your existing application. If you're going to leverage some of the CDAP tools around starting, stopping, gathering metrics, things like that, you wrap it in kind of an application configuration that just tells CDAP where the data sets are, where the MapReduce jobs are, where the flows are, and stuff like that. So it's not a lot of code, but it is a little bit of code to wrap your application up in so that CDAP can deploy it and manage it. Oh yeah, we were just asking about the difference between an application and a program, and how you would take an existing application and put it onto CDAP. So. Okay. Oh, one more. Sorry, go ahead.
Are you going to support managing data quality and checking for data consistency?
Yeah, so are you going to support data quality and data consistency, right? So we get that question a lot, and we are thinking about ways to improve that. Right now we have previews, so you can actually see what the data in your data set looks like before you start using it. And then from there, we're going to start thinking about ways to, if you noticed on some of those slides, let's see here, yeah, so this thing here, right, this is our tracker meeting, we're calling it. But it's a way for us to basically roll a lot of these different metrics up into a single number that helps you identify the quality of your whole data set, right? And that's evolving as well. So, for example, if you've got different rules that you apply and say, okay, if this field is null, or if this data set has this particular tag, manipulate the score up or down depending. So it's more, and the way we're thinking about it is more around just identifying data sets that may not be complete, not necessarily cleaning up the data that's inside the data set. At least with Tracker. We have other tools that you can manipulate the actual data itself. Does that help? That actually change the data in your data sets. So Tracker is really just looking at your data and measuring the quality, external to the actual information. Where we have other tools like Hydrator and some of the other stuff in Cask that will actually manipulate and update your data to clean it up. Okay, thanks guys.